Hello everyone, welcome to Learning by Solving YouTube channel. Today we discuss GATE 2021 Electronics and Communication Engineering. One more question. This is the fifth question. So let's solve this question. Here in the question is giving consider two 16-point sequences. So is giving 16-point sequences of x of n and h of n. Let the linear convolution of x of n and h of n be denoted as y of n. So is saying y of n is the linear convolution between x of n and x of h of n. So this is y of n. This is the linear convolution. So next, while z of n denote the 16-point inverse discrete Fourier transform of the product of the 16-point DFTs of x of n and h of n. What it is? Once again we read this. While z of n denotes the 16-point inverse discrete Fourier transform of the product of the 16-point DFTs of x of n and h of n, is saying that the z of n is inverse discrete Fourier transform of what? DFTs of x of n and h of n product. So DFT of x of n is x of k, DFT of h of n is h of k. So this product is what is saying here. This product x of k, h of k, this product inverse discrete Fourier transform is the z of n. Once again read, it will be clear for you. Well, z of n denotes the 16-point inverse discrete Fourier transform of the product of 16-point DFTs of x of n and h of n is what? Z of n. Then what is asking? The values of k for which z of k is equal to y of k is r. So what is the value here? It is, we are denoting it as n. Here he is denoting with k. So since it is just a variable, nothing difference here. So he's asking where this y of n and z of n value, what is the value of n for which y of n and z of n is having the same value is what he is asking. So let's try to find out here what is that value. So before that, let's see what is z of n here. So z of n is IDFT of x of k and h of k. This is nothing but the circular convolution of x of n and h of n. So this is the circular convolution of x of n and h of n. This is the z of n. So IDFT of the product of two DFTs x of k and h of k is nothing but the circular convolution of x of n and h of n. So ultimately what the question is all about is what is the value at which the circular convolution and the linear convolution having the same value. So that value is what is the point at which both are equal is what he is asking. So he is giving 16-point DFT, so it is lengthy to proceed with 16-point DFT. So we take one example to arrive at a conclusion that what is that point where both the circular convolution and linear convolution is having the same value. We take example of a 4 bit sequence, 4 length sequence. So let's say the sequence length is 4. Let's suppose x of n is equal to 1 2 3 4, and let's say h of n is equal to 1 1 2 2. So let's find out the circular convolution as well as the linear convolution, and we'll check where both are equal. So okay, let's proceed further. So first I am finding the linear convolution of x of n and h of n. So how to find it? So let's write x of n is 1 2 3 4. So let's say x of n is 1 2 3 4 and h of n here is 1 1 2 2. I'm using sum by column method to find the linear convolution. So how to find the linear convolution is take one and multiply with each and every element in x of n. So let's do that. 1 into 1 is 1, 1 into 2 2, 3 and 4. Then leave one column. So take another value in h of n and multiply with each element of x of n, that is 1 2 3 4. Let's do it. Let's leave one column and let's proceed. 1 into 1 1, 1 into 2 2, 3 and 4, and do similarly for the next 2 and 2. That becomes 2 1 are 2, 2 2 are 4, 2 3 are 6 and 8, and do the same thing for the rest of the elements as well. So once we completed this, let's add these elements. Now it becomes 1 3 7 13 14 14 and 8. This is the sequence of linear convolution of x of n and h of n. So this is the sequence. So now let's find out the circular convolution from here itself. So how to find the circular convolution here? So since both x of n and h of n is having the length 4 and 4, so circular convolution of length becomes maximum of the length of x and h. So here both the lengths are equal, so circular convolution length becomes 4. So circular convolution length becomes 4 here. Since this is 4 and these are extra terms here, we need to bring these extra terms here. It is 14 and 8, and let's sum these things. We will get the circular convolution. What is that? 15 17 and 15 13. This is the circular convolution. This is the circular convolution of x of n and h of n, and this is the linear convolution of x of n and h of n. Here what is the place where both the values of linear convolution and circular convolution are equal? Let's see. This is the place where both are having the same value. What is this place? Since we have taken n sequence length as 4, so this is the place. This is n minus 1th place, that is third place. This is 0th index, 1 2 3. This is the place. This is the place where we got the linear convolution and circular convolution as same value. So with this conclusion, let's apply for our problem. Here it is a 16 point sequence, so sequence length is 16. So where the circular convolution and linear convolution having the same value, it is at k is equal to n minus 1, that is at 15. K is equal to 15. At k is equal to 15, we are having the linear convolution and circular convolution is having the same value. So what is the answer for this question? That is k is equal to 15 is the only place where both linear and circular convolution are having the equal value. So answer C is the correct answer. Option C is the correct answer for this question. So let's sum it up. What we have done here is given x of n and h of n are the 16 point sequences. Is given y of n is the linear convolution of x of n and h of n, and z of n is given IDFT of x of k, h of k multiplication. This is nothing but the circular convolution of x of n and h of n. So the question is about where the circular convolution and linear convolution is having the same value. So for the simplicity, we have taken one example considering x of n and h of n is the sequences of length 4. We perform the linear convolution here by column by sum by column method, and then we also find out the circular convolution here. We find out that at n minus 1th place, the linear convolution and circular convolution having the similar value. We, after arriving this conclusion, we applied that conclusion for this question for the n is equal to 16 length sequence, and we arrived this is the place at 15th, k is equal to 15th or n is equal to 15th place where the linear and circular convolutions are having the same value, and thus the answer for this question is k is equal to 15. Option C is the correct answer. Thank you so much for watching.